All right, number 32, solve the problem. And we're told two different gasohol mixtures are available. One contains 5% alcohol and the other 12% alcohol. How much of each should be mixed to obtain 1,250 gallons of gasohol containing 10% alcohol? And so what we're going to do for number 32 is come up with a system of equations and then solve that system by either elimination or substitution, depending on what your preference is. And I like to use, for this particular kind of problem, which we refer to usually as a mixture problem, I like to use the box method. And this may or may not look familiar to you, depending on what you've seen in class. But several years ago, I created a reference sheet for word problems. And on this reference sheet, there is a section for mixture problems. And it guides you through how to set up the box method. If you don't have this reference sheet, and you may not, depending on who you had for intermediate algebra, you are welcome to email me directly and I'll be happy to send you a PDF copy of that reference sheet, and you'll be able to use it to study how to set up these word problems. But for number 32, we're going to label this top left box X and the box below it Y. And we always label these two boxes X and Y, no matter what the mixture problem is. This bottom box here, this bottom left box, we're going to put the total amount of the new mixture we're coming up with. And so we're told how much of each should be mixed to obtain 1,250 gallons. So that's the total mixture that we're making. So 1,250 gallons. And we have two different mixtures, right? One is 5% and the other is 12%. And that's what X and Y represent. X will represent our first mixture at 5%, and Y will represent the second mixture at 12%. And because the first mixture is 5% alcohol, we're going to go ahead and fill in this top middle box, which corresponds to the X, with 5%. But the way that we write 5% in the box method is in decimal form. So 5% in decimal form is 0.05. And then the Y mixture is 12% alcohol. And similarly, we're going to fill in 12% here in this box, this middle box, in decimal form, so 0.12. And the total mixture, this new mixture that we're coming up with, has to be 10% alcohol. And so we will label this bottom middle box here as 0.10, 10% in decimal form. And of course, we know we don't have to include that zero if we don't want to, but I'll go ahead and include it. So now we need to come up with this last column here. And in order to get this last column, all we do is we multiply from left to right. So from left to right, X times 0.05 is simply 0.05X. Left to right, Y times 0.12 is 0.12Y. And lastly, 1250 times 0.10 is 125. And once you have the box filled out completely, these far columns on the left and right become your system of equations. So we'll have X plus Y equals 1250. And then we will have 0.05X plus 0.12Y equals 125. And now we have our system of equations that we can either solve with elimination or substitution. At this point, a lot of students want to clear the decimal from this second equation. And so we are going to go ahead and do that. We'll go ahead and clear this equation of decimals. And because both of the coefficients here of our X and Y go to the hundredths place, we're going to multiply this entire equation by 100 to clear the decimal. So if we multiply by 100, what we'll end up with is 100 times 0.05x is simply 5x. And we know multiplying by 100 is the same as moving that decimal place to the right 2 positions. So that's how we come up with 5. Similarly, 100 times 0.12y, well, again, if we just move that decimal over 2 positions to the right, we'll end up with plus 12y. And here we have 125 times 100. Well, again, if our decimal is right there and we move over 2 positions and we fill in those places with zeros, we end up with 12,500. So that's our equation, our new equation when we multiply by 100. So I'm going to go ahead and get rid of that work there, and we'll move this up. And now you can see we have our two equations, no decimals, and we're ready to solve by either elimination or substitution. I think I'm going to go ahead and solve by elimination. And I'm going to eliminate the x variable. And so if we have a positive 1x here and a positive 5x here, we know we want the coefficients of our x's to be additive inverses. So let's go ahead and multiply this top equation by -5. And when we do that, we have -5 times x gives us -5x, -5 times positive y, -5y, -5 times 1250 gives us -6,250. And now let's see what happens. Well, 5x minus 5x, that goes away. 12y minus 5y gives us positive 7y. And then 1250, or rather 12,500 minus 6,250 gives us 6,250. And if we want to solve for y, we'll divide by 7 on both sides. And that leaves us with y equals 893. All right, so now that we've solved for y, what we can do is take this y value and plug it back into one of the original equations that we started with. And I think I'm going to plug it into this first equation here because this is a relatively simple equation. So let me erase all of this work. And again, if you need to copy this down, go ahead and pause the video, or go ahead, you can rewind, speed up, slow down. That's the beauty of YouTube. All right, so we had our first equation as x plus y equals 1250. Oops, 1250. But we now know what y is based on our elimination. So we're going to take that y value and plug it in. So we have x plus 893 equals 1250. And now we'll simply subtract 893 from both sides. And that leaves us with x equals 357. All right, so now that we've solved for x and y, let's go back and read the last question. And that's really important. With word problems, always go back and read the last sentence in the word problem, because the last sentence will tell you what it is they're looking for specifically. And so here they say how much of each should be mixed to obtain 1,250 gallons of gasohol containing 10%. Well, we can see here that X, which represented, remember, the mixture at 5%, so we can say 357 gallons at 5% is needed, and 893 gallons at, well, Y was paired with the 12% based on our box method here, so 893 gallons at 12%. And so our final answer for number 32 is 357 gallons at 5% and 893 gallons at 12%.